part C, you'll be finding the volume of the solid generated when you rotate the area S around the line y equals -1. Y equals -1 here is represented by this dotted line. It's not exact, but I want it all to fit on the graph. So when you rotate something about a line, the solid generated its volume can be determined by dividing up the solid into millions and billions of infinitely thin sort of cylinders or disks. However, when rotated about a line here, it's going to have a large hole in it. So how do you factor that in? By subtracting the line that you rotated about. This problem starts with a basic integral. And you're going to integrate every single sort of cylinder, or in this case, washer or donut ring, whichever you like most. And you're going to take the area or volume. You're going to take the volume of each donut. So that is pi r squared times height. Since you're traveling in a horizontal direction, h is going to be in reference to x. So infinitely small changes in x, which is represented by dx. Pi is a constant, so you can also pull that outside of the derivative, of the integral. So that turns out to pi r squared dx. And your radius is going to be found very similarly to how you find the area between these two graphs. You start by looking at the top function and the bottom function. In this case, the top function is 1/4 plus sine pi x. Bottom function is 4 to the power of -x. But you're going to need to, again, subtract the y line, which you're going to rotate it about. So you start with integral top function 1/4 plus 1/4 plus sine pi x minus -1 or plus 1. And since r is squared, you need to square that. Now you're going to subtract this lower equation, 4 to the power of -x minus -1, which is again plus 1. You square that too. Add in your dx. Never forget your dx, which is a point itself on the AP exam. So this integral will give you the volume of this area S rotated about the line y equals -1. One more thing, you need to specify from where you're going to take this integral. So since this is basically part B again, you're going to do left bound is 0.178 and your right bound is 1. After running that through your calculator, you're going to get 1.451. So 1.451 times pi. Don't forget about this pi outside. So when you multiply that by pi, you get the answer 4.55876, or rounded up 4.559. And that will be the approximate volume of the solid you create when you rotate S about the line y equals -1. Thank you for watching, guys. If you need more help, please wait to the end of the video and I will give you some problems that you can also do. These are AP problems that also have to do with calculating the area between two lines and rotating them about an axis. You guys are going to do great.